Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. As I promised some of you, here is another Algebra 1 Regents exam, and this one is from June 2023. And as usual, I will do the first part today, and then tomorrow I either do the rest or I'll break them into two parts. So we have four parts. We look at part one, which is made of 24 problems. Each one is worth 2 credits. And then we'll do so these are the multiple choice, and then we'll do the others either tomorrow or the next 2 days. Okay, so the first problem or the first question says, the expression 9m squared minus 100 is equivalent to what? You can see they are already factored to you with a plus or minus. So that has to let you think that are these like perfect squares? And sure enough, you see that 9m squared is 3m squared, and the 100 is 10 squared, right? So you have a difference of two squares. And we know that if I have x squared minus y squared and I'm factoring it, I say x minus y times x plus y, or vice versa. It doesn't matter. So I can say the same thing, 3m minus 10 times 3m plus 10. It's the same concept. And you can see that number one is that, right? 3m minus 10, 3m plus 10, so it must be 1. So that was very quick. You don't want to waste time, right, on these types of problems. Which expression represent an irrational number? So we know irrational numbers are something that cannot be expressed as a ratio, like any square root of non-perfect squares, because all of these are square roots, right? I know the square root of 16 is 4, the square root of 1 is 1, so that's fine. Number 2, square root of 25 is 5, square root of 4 is 2, so that's fine. Square root of 36 is 6, but the square root of 7 is irrational. So it's number 3. Of course, you can check the next, but you cannot have more than one. Just to be on the safe side, square root of 49 is 7, and square root of 9 is 3. Which linear equation represents a line that passes through? What's the meaning of passing through a point? It means that if I substitute the coordinates of this point, I get the left-hand side equals the right-hand side. So we start. We say y is negative 8. So is the right hand negative 8? Negative 3 times 2, 2 times x. X is negative 3. So 2 times negative 3 is negative 6. Minus 2 is negative 8. Yes, it passes. There is no reason to check the rest. So it's number 1. The expression 5x squared minus is equivalent to what? So just subtract. The first one is 5x squared minus x plus 4. Now you have to be careful when you subtract, because when you subtract a negative number, it becomes a positive. Some people, they check the first and then they forget about the rest. So not a better way, but an easier way to help you. You see what I'm going to do? Above those, I'm going to change all the signs. I have a negative 3, I'm going to make it positive 3. I have a positive x squared, I make it negative x squared. I have a negative x, I make it positive x. I have a negative 2, I make it positive 2. And now I'm adding. Because when I distribute, that becomes 3 times negative x squared is negative 3x squared. 3 times x is positive 3x. 3 times 2 is positive 6. I'm done. 5 minus 3 is 2x squared. Negative 1 plus 3, or 3 minus 1, is plus 2x. 6 plus 4 is 10. So I get 2x squared plus 2x plus 10. That's number 2. You see that all of them have a little variation, because if you do they anticipate that you might have done, so for example, -3 times -2, you make it -6 or something, and you say 4 minus 6 is -2 or something like that. We don't have -2, but they try to anticipate errors and to let you get confused if you don't know. So if you fall into this trap a lot, just change the negative outside as positive and change all the signs inside the parentheses. Okay. The 24th term of the sequence is, okay, I know that to find a sub n, I say it's a sub 1 plus n minus 1 times the increment d. That step that we keep adding or subtracting. Okay, if you forget, I mean, it's really so easy that you can, excuse me, try your own, right? So for example, you say, okay, if I have a sequence, just 1, 2, 3, 4, 5, 6, and I want to find the 6, how do I find? Notice I'm adding 1 every time. So I say it's the first plus, I need to add 5, but the difference is only 1. So that must be 5. So 6 minus 1, right? So you are subtracting 1 from, if this is the 6th term, I subtract 1 from it. So if this is the 24th term, I would subtract 1 from it. And I would say a sub 1 is -5 plus n minus 1 is 23 times, and the d here, you see, I go down 6, -5 to -11, -11 to -17. So you always take a term and subtract the previous one. So you say, for example, -23 minus -17 equals -23. Remember, I'm going to make this positive and this positive, so it would be plus 17 equals -6. Use your calculator. -6 times 23 is -138, and -5, both of them are negative, so I add them up and I get negative, do I have? Yeah, -143, which is 2. Okay? Number 6, when completing the square, which equation is a correct step in the process? Well, when you complete the square, I explained that in one of the other videos that you can find in the mathematics playlist. But basically, the first thing we do, we open parentheses and write x squared minus 18x. I leave a blank, and I move this to the other side, meaning I'm going to subtract 77 from both sides. So equals -77. Now, what do I add here? And what is the square? What is the perfect square becomes? First of all, I divide the -18 by 2. If I divide -18 by 2, that's -9. So I can easily write here x minus 9 squared. -9, because when I divided the -18 by 2, I get -9. So right there, I can see the answer, right? -9 squared. It's the only one that has -9 squared. But to continue, after I divide by 2, I take the -9 and square it. When I square it, it becomes 81, positive 81. And since I added 81 to the left-hand side, I also add 81 to the right-hand side. And 81 minus 77 is 4. Yes, it is number 1. Let's move to the next one. Which function will have the greatest value when x is greater than 1? Well, you can check them out with any number, but usually, first of all, I know that the square grows faster than the linear. The cube grows faster than the square, but the exponent moves or increases faster than any of these, even if this is x to the 100. Okay, it grows faster. So you can check, you can pick, for example, any number. Let's say I pick 5. I don't need to do that, but just to be confident. If I pick 5, forget about this for a second. 5 times 2 is 10 plus 5 is 15. 5 squared is 25 times 2 is 50 plus 5 is 55. 5 cubed is 125 times 2 is 250 plus 5 is 255. Now put 5 here. If you put 2, the 5 becomes 25. If you put 3, it's 125. If you multiply by 5 again, you get 625. If you multiply by 5 again, you see we are already in the 1,000, right? 3125 times 2 is 6,250, much higher than any of these. So again, it's number 1. But the exponent, we know that it grows faster than the linear or the square or the cube. Okay, so what do we have? Okay, Mike uses the equation b equals 1300 times 2.65 to the x to determine the growth of bacteria in a lab setting. The exponent represents what? Is it the total number of bacteria? No, the total number of bacteria is b. The percent at which the bacteria are growing? Now, that's what's between the parentheses. The initial amount of bacteria? No, it's this. Number of time periods? Yes, it's the number of time periods, definitely. Right? A company ships an average of 30,000 items each week, meaning 30,000 per week. How do you can write this, the units mathematically? 30,000 items per meaning division, right? Per week. The approximate number of items shipped each minute is calculated into which conversion? If I'm solving that, if they don't give me the answers, I would say items per week, I want them items per minute, right? So do I convert the items into minute or the week into minutes? Of course, the week into minutes. I don't know how many minutes are in the week, so I can take them step by step. For example, I know, notice that if the week is in the denominator, I want to make it in the numerator so they can cancel out. And I want to make the bottom days. Right? Days. So right here, you see items per week, items per week, items per week. Oh, I can exclude 3 and 4 because they are week per items. Now, I multiply by week, and I know that 1 week is equivalent to 7 days. So I have to multiply by 1 and divide by 7. So it must be 2. You see, I don't even need to continue. But if you continue, you say, oh, I don't want days, I want minutes. I don't know how many minutes in a day. Well, I know 1440, but if I don't know, I'm going to say, oh, days in the denominator, and I don't want it. So I'm going to write it in the numerator and makes hours in the numerator. But is 1 day equal to 1 hour? No, 1 day equals 24 hours. And then I still don't need hours. Notice here I got done. I got away with the days. I don't want days. Oh, now I don't want hours, so I write it on the numerator, and I know I need minutes, so I put it in the denominator. But 1 hour is 60 minutes. So now when you look at number 2, 30,000 items divided by 1 week times 1 week over 7 days times 1 day over 24 hours times 1 hour time over 60 minutes. So I know it's number 2. At the end of the day, I have items per minute. It's very simple. All what you need to do is to make the conversions one step at a time. If you know how many minutes in a week, you can do it quickly, but you cannot check. So you have to take it step by step. If I ask you how many how many items are produced every minute, and you memorize, how many minutes in a week, you can just divide by that number, which is 7 times 24 times 60, and get done with it, which would be what, 100,040 or something? I don't know. 80. A function is graphed below. A possible equation for this function is what? I know when the function or the graph crosses the x-axis, then the factor that is raised to an odd power, meaning 1 or 3 or 5. But if it's 1, it's just a straight line. If it's 3 or 5, you will see some curvature here. We are not going to, you will learn that in Algebra 2. But if it doesn't cross, if it just touches and come back, then this factor must be raised to an even power. So the either 2 or 4. And again, if it's 4, it stays down for a while and then go back. But again, you learn that in Algebra 2. So I have -3, meaning there is a term x plus 3, and it's raised to an odd power. And this is 1, 2, so there is x minus 2 raised to an even power. I have here them backwards, so it's not 1. Here, there is no squares, so it's not 2. Here, it's the only one that has x minus 2 squared. Even, because it touches and goes back, so it must be even. And x plus 3 is odd, so it's number 3. Notice this one has x minus 12. I don't know where the 12 comes from. The 12 is outside the figure anyway. Okay, so it's number 3. It's very easy to check that. If g of x is negative x squared minus x plus 4, and you want to calculate g of negative 4, again, this is one of the easiest thing to do. Every time you see x, you take it out and write -4 instead. First of all, I have a negative sign, so that's a negative sign. I have an x, so notice I will use parentheses just to write -4 instead of x squared. Minus, I have an x, so between parentheses, notice both of them are, I could have said -x squared minus x plus 5. And every time I see an x, I replace it with -4. There are no more x's, so no more -4s. PEMDAS, I have to do the parentheses first. I have a -4, the exponent next. -4 squared is positive 16, and I have a negative sign outside, so it's -16, not positive 16, as unfortunately some students do. They multiply the negative by the negative, which they do the multiplication before the exponent. Okay, so you have to if that was a cube, it would be -64, and then negative times negative is positive. So it would have been positive 64. So be careful. You do the parentheses and the exponents first. And then -4. Now this is already done. So you multiply it by negative. Negative times negative is positive 4 plus 5. -16 plus 4 is -12, plus 5 is -7, and -7 is 2. Next, a movie theater's popcorn box is a rectangular prism with a base that measures 4 and 6. And the height is 8. So this is 4, this is 6, this is 8. So the volume is 4 times 6 times 8. To create a larger box, both the length and the width will be increased by x. Length and width. So x plus 4, x plus 6. The height will remain the same, so 8. So what is the volume? X plus 4 times x plus 6 times 8, right? Width times length times width times height. It's the first, no, it's not the first, it's the second one. 6 plus x or x plus 6 times 4 plus x or x plus 4 times 8, so it's 2. Notice here they added x to the height. Here it's addition, not multiplication, so definitely they are not correct. Number 13, the expression 300 times 4 raised to the power of x plus 3 is equivalent to what? We know that if you have a to the x times a to the y, or x to the a times x to the b, for example, you get a times x plus y. Meaning, if I have addition in the exponent, it means a is raised to 1 times a raised to the second. So if I have 4 to the x plus 3, it must be 4 to the x times 4 to the 3. Uh, 4 to the x times 4 to the 3 is number 1, right? The 300 is a constant, so I don't care about that. If I have the same base raised and a multiplication, the multiplication, when you do the power or the exponent, you add the exponents. So this is equivalent to that. Ashley only has 7 quarters and some dimes in her purse. She needs at least $3 to pay for lunch. Which inequality could be used to determine the number of dimes she needs in her purse to be able to pay for the lunch? Pay for the lunch meaning you have at least to have $3. So I can exclude the 2 on the right because it says the money she has is less than $3, which doesn't make sense. But which one of them? Notice that if I have a quarter and the quarter is $0.25, and they told you she has 7 quarters, so I multiply 0.25 times 7, and that's how I got the 175. So I cannot say what this is saying. If you have 7 quarters and a dime, because a dime, the number of dimes is d. So if you have 1d, or the value of the dime here would be 1, so it's not correct. This is the number of dimes, and this is the value of the quarters. How can you add numbers and value? No, the value of the dime is 10 cents. That's why I need to multiply it by 0.1 to get the total amount of money that you have within the dimes. Okay, so this is 7q, meaning, I'm sorry, you said 7. 7 times or 0.25 times 7. 0.25 is the value, 7 is the number. This is 0.1, which is the value of a dime, times the number of dimes, should be greater than or equal to 3. Of course, you are not solving, but if you are solving, then you will have at least 13 dimes to get the $3, right? Because if you have 12 dimes, these are $1.20, which is, so you will get $2.95, unless the merchant is nice and will give you that. Okay. The formula for the area of a trapezoid is area equals 1/2 the sum of the parallel bases times the height. If you want to solve for the height, like you do in any algebra problem, right? If I want to solve for h is multiplied by 1/2 and multiplied by b1 plus b2. So first I have to multiply both sides by 2, right? 2 times 2. So these would cancel. So I get b1 plus b2 h equals twice a. And then to find h, I will divide by b1 plus b2 both sides. So these would cancel, and I get h equals twice a over b1 plus b2, which is 4. Number 16. The function f of x is the absolute value of x is multiplied by k to create the new function g of x is k times the absolute value of x. Which statement is true about the graph of f of x and g of x if k is 1/2? Meaning if g of x equals 1/2 absolute value of x. G of x is a reflection. No, it's not a reflection. The reflection will have either a negative sign here or a negative sign for the x. If it's here, you are reflecting over the y. If it's here, you are reflecting over the x. So it's neither one or two. G of x is wider. Well, if you have 1/2, it means the y is narrower, meaning shorter. And if you squeeze something down, it gets wider. So yes, it is number 3. Okay? It's not narrowed. Narrower if that was greater than 1. Because that means the y is taller, so the x gets narrower. Okay. Let's move to the next. Some adults were surveyed to find out if they would prefer to buy a sports utility vehicle SUV or a sports car. The results of the survey are summarized in the table below. We surveyed 250, 59 of them are males and 181 are females. And then they tell you that on the numbers of adults that preferred sports car. So you only care about this column. This is a conditional probability, right? Approximately what percent were males? So we know that the probability of male given sports car equals the probability of males, and we can write it and if you know that this symbol is for and, divided by the probability of the condition, which is SC. Well, when you talk about probabilities, you can translate that into numbers. So I can say the number of, if I want this probability, it becomes the number of males and sports cars. Here are males, here are sports cars, so it's 38 divided by the number of the people who like sports car, which is 84. You can simplify by 2. It doesn't matter. You are going to use the calculator anyways. It looks like it's around, half of that is 21. This is closer, slightly less than half, so it must be 2. But you can say 38 divided by 84, and then you multiply by 100. No, you don't multiply by 100. Well, multiplying by 1. I thought they want percentage, but they want probability 4.452, meaning when you multiply by 100 to get a percent, like we said, you get 45.23, so it's number 2. The solution to 2x squared equals 72 is, of course, if I divide both sides by 2, I get x squared equals 36. Common mistake, x equals 6. No. X, you take the square root of both sides, but when you take the square root, you know the square has 2 answers, so it must be plus or minus. So you get x equals plus or minus 6, which is 4. The 3 quadratic functions are given below. One is given to you as a function, one as a table, one as a graph. Which of these functions have the same vertex? Okay. So let's see. The first one, notice that the minimum value you can get here is x. This is a parabola opening up, and it has the vertex x is 5. The y is 5. right? And this happens when x is -2, by the way, right? Because -2 plus 2 is 0, and 0 squared is 0, so you get 5. If you make x any other number positive, if I say -12, -12 plus 2 is -10, but when you square it, it becomes positive 100, so this would be 105. You can never find anything less than 5, so that has a vertex of 5. Number 3 also has a vertex of 5. 1, 2, 3, 4, 5. So this has a vertex of 5. This has a vertex of 5. How about the second one, the table? That's also a quadratic function. At -4, it was -3, and then it became +2, +5, stayed at +5. So the vertex occurs at -1.5, and it must be slightly higher than 5. It cannot be 5. Why? Because if I have a parabola that looks like this one, if this is 5 and this is 5, then definitely the vertex is higher than 5, right? I know it's opening down. So like I say here, this is 4, this is 4. So the vertex must be greater than 4, right? So this is not, it should be, they give you 5 and 5 to trick you, but it cannot be the vertex. The vertex occurs only at one location, not two. So it's only 1 and 3, which is number 3. Okay. Now we move to number 20. The domain of the function x squared. Well, take it like from me, or you already learned that at school. If you have a polynomial, a polynomial, like you have an x squared, x cubed, x 100, whatever. Any polynomial is continuous, meaning it has a domain from -infinity to +infinity. There is no reason to think. Okay, it will never have a discontinuity in the middle or something. So this is number 2, -infinity to +infinity. It shouldn't take you 5 seconds. A father makes a deal with his son regarding his weekly allowance the first year. He agrees to pay his son a weekly allowance of $10. Every subsequent year, the allowance is recalculated by doubling the previous year, so the 10 becomes 20. Oh, and then subtracting 8. So it would be, for example, 20 minus 8, or 12. And then the 12 will double again. It would be 24 minus 8, which is 16, and so on and so forth. Which recursive formula can be used to calculate the son's weekly allowance in future years? So the first, now this is, of course, doesn't make any sense, right? Because A1 should be in the negative. He will take money from his son. Unless you go to year 4, when the poor guy will not pay his father. Okay, number 2. A sub n equals twice the next year, because n plus 1 meaning the next year minus 8. But no, of course not. How about this one? A1 is 10, okay? An plus 1, which is, for say, the second year, is 2 times 10 minus 8, yes. How about the last one? The next year is 2 times a sub n minus 8. So you see, it's 2 a sub n minus 16. So the guy would, you multiply a sub n, which is 10, minus 8, it's 2, times 2 is 4. So after taking $10 in this year, next year he will start taking $4 only, and then he would pay his father again. So again, it has to be number 3. What is the solution of to the inequality below? Well, you have an inequality. So first of all, we have to have the x's alone and the numbers alone. So for example, I can subtract 1/3 x from both sides, or add 2/5 x to both sides. It's up to you. And then I don't want any x's here, only, so I have to subtract 4 from both sides. These cancel and these cancel. So you get 2/5 x, negative 2/5 x minus 1/3 x equals, oh, I'm sorry, greater than or equal 11. 15 minus 4, right? So that's a negative sign. You can take a common denominator of 15. You have a negative here, and then you add those, or you keep the negatives for each term. Do you see what I'm saying? So you either say 15 over 5 is 3 times 2 is 6, and then you say plus because I factored the negative out. Or you can say negative 6 minus, and when you divide 15 by 3, you get 5. Both of these are correct. Okay, I can say negative 5 minus, negative 6 minus 5 over 15, or negative 6 plus 5 over 15. In both cases, first of all, this is greater than or equal to 11. I simplify, so I get negative 11 x is greater than or equal over 15 is greater than or equal to 11. And then I can divide by 11 both sides. So I get negative x over 15 is greater than or equal to 1. And then I multiply both sides by negative 15. But when you multiply by a negative sign, you invert the inequality. If it's greater than or equal, to make it less than or equal 1 times negative 15. Now the negative 15 and the negative 15, the 15 and the 15 cancel, and the negative and the negative cancel because they become positive, and you get x is less than or equal to negative 15, which is number 3 again. By the way, you can always check your answer, right? If I say x is less than negative 15, so maybe I make it divisible by 5 and 3. So to end up with an integer number. If you have time, you can quickly use your calculator and say, oh, I'm going to use x equals negative 30. Why negative 30? Because it's both divisible by 5 and 3. If I make it 15, I will get the same thing. So you can, but it's better to say 4 minus 2 over 5 times negative 30. I get 16. Okay, what about the right-hand side? 1/3 times negative 30 plus 15. I get 5. Yes, 16 is greater than 5, so I did it correct. Okay? But we know that when you multiply or divide by a negative number, you switch the inequality. I'm sorry, I didn't try the x here. I said x, but for some reason I didn't try it, so I hope I didn't confuse. Which statement is correct about the polynomial 3x squared plus 5x minus 2? It's a third degree. No, it's a second degree. It's quadratic. It's a third degree. No, it's a second degree, I said. It's a second degree polynomial, yes, with a constant term of 2. No, constant is negative 2. It's a second degree polynomial, of course, that has to be the correct one, with the leading coefficient. The leading coefficient is the coefficient or the multiplier of the highest degree. Highest degree here is 2, meaning x squared, and the leading coefficient is 3. Yes, it is 3. And finally, the last question. A store manager is trying to determine if they should continue to sell a particular brand of nails. To model their profit, they use the function P of n, where n is the number of boxes of these nails sold in a day. A reasonable domain for this function, domain meaning the values of x or n in this case, would be non-negative integers. Yeah, that's the correct one, right? You can You may not sell anything, then n is 0, that's a non-negative integer, or you cannot sell negative numbers of boxes, right? So it has to be that. And just to check rational numbers, no, you are not going to sell 7/19 of a box, right? Because he's selling p of n, okay? Uh, real numbers meaning fractional. No, he's just selling number of boxes. I don't know. It's like, what if they allowed, doesn't say explicitly that they sell nails in boxes. Maybe they sell part of that. I don't know. But it makes sense to say non-negative integers since n is the number of boxes. And it's not integers because integers can be positive or negative. So I would say 1, not 3, but that's a little tricky. I don't see, it has to say that he sell a particular brand of nails, but he sells full boxes of a particular brand of nails. Doesn't allow you to sell half a box or something, or few nails. Anyway, so in that case would be a rational number, but rational number also and real numbers can be negative. So that is the trick. All of these can be negative except the first one. So it has to be the first one. I'm sorry, I didn't realize that. Okay, so this is the first part of the test. As I said, we have 13 more questions for parts 2, 3, and 4. I may do part 2 tomorrow and then 3 and 4 the day after, or we'll see if we can fit them all, because so far these simple ones took almost 3/4 of an hour with the explanation. So we'll see. Probably I'll break it into 2 parts. Okay, thank you very much for your time. If you have any questions, please let me know by sending me a comment. If not, then I wish you all the best. Until tomorrow, bye.